Okay, we are now recording to the cloud. Who knows where it will end up in the cloud, but it'll be your job to find it, Suresh.
All right.
As Suresh was introducing me, he said that I've been doing this for a while. That's a very nice way of saying that I'm old. And I have been doing this for a while, so I think I've been in the data platform and BI space for about 25 years now. It depends on what you count, but yeah, I do have a passion for business intelligence. I've been working in the Microsoft data platform and BI platform really since its inception, first working with SQL Server, and then tools like reporting services, integration services, analysis services. I think I started working with analysis services circa version 2000, so it's about 20 years ago. And of course now with Power BI. And I think it's notable that Power BI really sits on top of these very mature established technologies. At its core, Power BI, you may not know this, that when you install Power BI Desktop, it actually installs the SQL Server Analysis Services tabular engine on your computer. And that's the tabular modeling technology that you're actually using. It is actually SQL Server Analysis Services in a sandbox. So anyway, my blog site is here, and this presentation is actually out on my blog. You can download a PDF copy of the slides and the PBIX files that I'll be using. It's already out there at SQLServerBI.blog or SQLServerBI.blog. You can also get to my blog at SQLServerBIblog.com, and you're welcome to reach out to me on Twitter. So the topic of my presentation is really around understanding the core components of data modeling and understanding why that's important. I think one of the challenges that we have with Power BI is it doesn't force us into using proper data modeling habits and design patterns. You have a lot of freedom to import data in a variety of shapes, but you can very quickly get yourself into trouble if that data is not shaped correctly. I'm going to talk a little bit about what that means and why that's important. And if you've had some experience trying to create data models with Power BI and do things like many-to-many relationships and bidirectional filters, you'll understand my tongue-in-cheek reference to ambiguous relationships and how when a model grows sufficiently complex that it can be difficult to continue to extend that data model. So we're going to talk about that a little bit. All right, so the world is flat. We can build reports on top of flattened data. And a lot of folks who live in the financial space, of course, are accustomed to seeing their data in a flattened form. So here's a very simple example of what I might call flat table or flattened data model. So if you look at this order information, you can see that we have some dates here. So an order record has an order date, a due date, a delivery date. We have some company information here. You can see that there's a company key or an ID and then the company name. We have some product information in this flat table consisting of category, subcategory, and the product name itself. And then there's some numeric values over here that I've highlighted in green. And if we break down this very simple example, we could look at the date values as a dimension of our data. So over on the right side, we have the facts. We have the things that we want to count or summarize or average or aggregate in some way, perform calculations over the top of. And then the rest of these columns are really attributes of what we call dimensions, which means that that's how we describe the facts. We're going to filter this aggregate data based on a dimensional attribute like a date, and maybe a part of the date, maybe the year, quarter, month, week, or day. There could be a fiscal calendar, so we could have our own custom, fiscal periods or financial reporting periods. But again, it's related to a date. So this is great for simple sets of data. And there are products that are really optimized to work with flat table data. Power BI will work with flat table data up to a point, but let's think about a product that's really optimized to work with a table, maybe one that's named after the French name of table, like Tableau. So that's the approach that a lot of vendors have taken. Microsoft have really kind of leaned toward a different type of modeling schema, and this is the dimensional model. Now, if you're not accustomed or if you're not familiar with the concept of a dimensional model, this is not a new idea. These ideas, these concepts have been around for a very long time. Let's think about what a dimensional model is. So I was describing facts. Facts are the things that we count, that we aggregate, that we calculate. Those are the things that we really care about. What quantity of products have I sold? What's the total revenue that's on order, that has been delivered, that we've actually received from customers? Those are facts. And then surrounding the facts are our dimensions. And there may not be 5 of them. There could be 2, there could be 40. But we refer to that as a star schema simply because I think a star kind of describes the concept. Here's the materialization of a star schema in a Power BI data model. And we're going to dive deep and look at some real examples of this. A dimensional model really is a general best practice. It really is the way you should think about trying to model your data for analytic purposes. It's going to give you improved performance. You're going to get more accurate results just because the data's tame. It's in a shape that the modeling engine can work with, and it's easier to manage it. It's not an absolute for simple, it's not an absolute for simple dimensional attributes. What I mean by that is if we have a table that contains, let's say, the customer geography and our quantity and our sales amount and other numeric columns, it might be okay for that to exist in the same table, as long as that's simple data and easy to manage. You don't necessarily have to force all of your attributes out into separate dimension tables, but it is a general best practice. It's just not an absolute. There are rare exceptions for doing that. All right, well, where did these dimensional modeling rules come from? Who came up with this idea? Well, this is a group of people that are really credited with coming up with the star schema. This is the Kimball Group. The gentleman sitting in the center on the bottom there is Ralph Kimball. They were in business for 30 years. They did consulting work back in the days when the concept of a data warehouse was fairly new. And they're not to be confused with this group of people. It does look like a family photo there, but don't confuse them with actors. All right, you can go to the Kimball Group today. They actually went out on a high note, meaning that about 6 years ago, Ralph Kimball closed up shop. They had done business, they had made their money, they wrote several books. In fact, I have several of their books here up on my bookshelf right here. So here is the Data Warehouse Toolkit. In my opinion, this is the Bible of dimensional modeling. It's an old book. It's been around for 20 years or so. But the concepts in the Dimensional Warehouse Toolkit, in my opinion, are enduring, and this is the best place to go to really figure out how to solve more complex business problems through data. So the Kimble Method, you can go to their website, you can get detailed information about the Kimble Method. The Kimble Method describes a process that looks like this in very simple terms. One, you select a business process. What is the thing that we need to report on? Customer sales. Declare the grain. At what level of detail do I care about customer sales across my, let's say, store geography. Do I need to go all the way down to the store, or is it okay to be at the city, the state, the country, the continent? Across dates, do I need to go down to the date? Could it be at the monthly level, or the quarterly level, or the yearly level? And so you're going to go through this exercise for each of your dimensions. And just remember that the deeper you go, the more volume you have, the more data you have to store, and potentially there may be a performance impact. Identify the dimensions as I just described, and then identify the facts. And when you're dealing with real business data, you may have multiple facts. We could have orders, we could have sales, we could have inventory, and that data might need to exist in separate fact tables. All right, and then there are steps toward fleshing that out and actually building a data model with the understanding. I'm not going to walk through all of this. You can go and read about the Kimble method that will take you through this process in a very orderly fashion. But it has to do with loading the data at the right level, what we call a detailed atomic data, loading that into a grouped schema that supports our reporting requirements. So I think that the last step that I called out here, and I'm sorry, I just hit the wrong button. The last step that I called out is that BI projects are never done. Reporting projects are never done, and that's just a reality. We're never going to understand all of the requirements up front. And so there's this point in time where you really need to do due diligence and say, all right, I need to understand enough about my requirements where I can build a data model as a prototype, and then we can iterate over that and either learn enough from that so that I can throw it away and start over on the production model, or build something that's durable enough that I can iterate over. And as we discover more requirements, we can continue to iterate. The risk, of course, is that at some point we may realize that our data model is just not durable enough to meet future requirements. And at that point, it would be appropriate to step back and rebuild. Fortunately, we're working with tools that are fairly easy to use and not real expensive to use if we need to start over. All right. So the first concept that I want to get into is role playing. Not this kind of role playing, but this kind of role playing. In the sample set of data that I'm showing here in this screenshot, we have airline flights. And this is a real set of data that I think is an excellent example. The classic example is order dates, but that's kind of a dead horse that we've beaten. Think about a flight. A flight leaves from an airport, it arrives at an airport, hopefully. And so we have the concept of an airport. That's a dimension. It's a list of airports. But an airport serves two different roles in terms of flights. You have the departing airport, and then you have the arriving airport. So they're two separate roles. They serve two different purposes. In terms of dates for sales and orders, as I described earlier, a date could represent the order date or the due date or the ship date, the delivery date. And so those dates serve separate purposes. Therefore, they should exist materially, perhaps, as separate dimensions in your data model. And so here's an example of that. And I'm going to jump into the model and actually show you how this works. Those of you who have worked with SQL Server analysis services in the past, and I know, Suresh, you have some experience working with multidimensional models.
Yep.
When you created a relationship between a date dimension table and a fact table that had three different keys, like we have in this example, the multidimensional design experience actually went and manufactured three different date dimensions for us, called role-playing dimensions. Power BI doesn't do that. It doesn't do it automatically. So you would actually have to create three different copies of your date table, which is really exactly what the multidimensional designer was doing for us. It was actually materializing that dimension table three different times. There's nothing wrong with doing that. Obviously, it uses up a little more space, but that is not a bad design pattern at all. Okay, let's just jump in and start looking at a data model. And I just want to make sure that you can still see my screen. I know that that sometimes you can share a window and then you don't see the screen. So Rash, can you just verify that?
I can see your screen. I can see the Power BI desktop.
Excellent. Okay, so let's jump over here and just quickly take a look at these three different relationships. Now, when I loaded this data, if we jump over to the Power Query window, which showed up on another screen, I'll pull that down here. You can see that I created one base table. Bear with me a little bit. Let's see, there's my base generated date. So in Power Query, I have created only one date table. I've really only had one source. Now this particular date table, I didn't actually import from a database. I actually generated it here in M, and that, you know, there are a variety of techniques that you can use to do that. Our purpose isn't to get into the guts of Power Query, but I just wanted to show you where this came from. So if you have a data warehouse where you have a reference date dimension table, it just makes sense to import that because you already have that. But a date dimension table needs to have one row per date. And since that didn't exist in my data source, I just went ahead and generated that using M. It's a very simple thing to pass two parameters to a simple expression here and say, okay, I want to start with this date, I want to end with this date. That generates a list. I did create those as numbers, and then I convert them to dates. There we go. So you can see that I've done that. But my point being that I only have one real date query that I've created. And then I'm going to right click and reference that to create my order date table, my due date table, and my delivery date table. All right. Then I close and apply. Those three tables get loaded into the actual data model. And then based on my date key, which in this case is date key, which is a numeric key. I just realized that I've rebooted my computer since the last time I ran Zoom It. So let me get that started so that I can zoom in here. I'm just going to pull this over here so that that's easy to see. All right. And so you can see that the relationship is between the date key here and then the order date key or the delivery date key or the due date key in my fact table. All right, so three separate copies. The reason I do that is so that I can slice on any of those things. I can say, I want to see all of my products that were ordered in this range of dates, maybe in the month of February, but then were delivered in the month of March. And so I can control those separately. All right, let's talk about bidirectional filters. I actually don't have bidirectional filters in this model. I realize now that I'm taking a look at it. Let me bring that back to the screen. What is a bidirectional filter and why do I care? So if I have a relationship between two different tables, that relationship will support filtering in one or two different directions. What that means is that in this relationship between the customer table and the sales table, by default, you can see that that's a one-to-many relationship because there can be multiple sales records for the same customer. But in the customer dimension table, I'm only going to have one record per customer. Therefore, whatever key I use in this table, the left end of that relationship, must be unique. That value has to be unique. So in the case of the date, I only have one row per date in my date dimension table, and if I didn't, then it would break that. Power BI would complain. But you can see that the filter direction points from customer to sales, and what that means is that in my report, when I choose a, let me switch this and say where that's to the product subcategory. When I choose a subcategory like I've done here, that's going to filter my facts against that fact table. However, when I choose a fact, that is not going to filter this table, at least in that case. Okay, so that's a single direction filter. A bidirectional filter lets me choose a sales record and then filter products. You might think, well, that would be a cool thing to do. Why wouldn't I just want to do that? Because there's a performance cost. And so if you use bidirectional filters, there's always going to be a performance hit. If you use them across multiple relationships, so between, let's say, you know, the dimension table related to my fact and then to another dimension table related to that one, that's going to slow things down quite a bit. So you want to be very, very careful about overusing bidirectional filters, and you can get yourself into trouble if you use them too much. All right, reminds me, 3 years ago, I was attending a session at the PASS Summit. Alberto Ferrari was speaking, and he wanted to make the point about just how horrible bidirectional filters were. And he said, and I quote in his accent, "If you use a bidirectional filter, you will go to hell." And so I've always remembered that, and I think about that every time I'm tempted to use a bidirectional filter. Here's an example of two bidirectional filters. And in this case, we might argue that this is necessary, or we could argue that maybe it's not. So if I have a fact table here and maybe a fact table here, and they're joined by two different tables, and if I need to be able to select something here and filter this table here, I would have to have two bidirectional filters. And I can tell you that in the model where I built this, that was extremely slow. All right, many-to-many relationships. So a many-to-many relationship, there is actually a filter built into Power BI to automatically do many-to-many relationships. It's not a feature that many people use. The typical design pattern for a many-to-many is to create a bridge table. So in this example where I can have many customers associated with a transaction because the transaction is related to an account, but I can have multiple customers on that account. If I want to see all of the customers related to a transaction because of that membership in the account, I would have to have a mapping table, a bridge table between account and customer. So in order to actually facilitate that, in order to actually get to the customer from the account, I would have to put a bidirectional filter on one side. Okay, so let's talk about relationships. I'm going to give you some relationship advice. And then we're going to dive deep and take a look at some specific examples. So we can do some very creative things within Power BI. And I'm just going to jump in and do a real quick demo and then explain how this was done. So I'm going to not use that one, but let's jump over here. And let's see. That's exactly what I wanted to do. All right. We're actually just going to park that matrix to the side and we'll ignore it for now. And I'm going to come over here and we're going to remove that column grouping. All right. So I want to have a single measure that will give me my aggregate quantity for any period that I select. So as you can see, I have my date hierarchy here in this table. And I'm going to say, if I just want to see the quantity for the current period, so in this case, January 2nd of 2007, 113 is the online sales quantity for that current period. But let's say that instead of relative to January 2nd, I would actually like to see the prior year value. Okay, and so for the prior year, and this is in the entire prior year, that's 44,000. Let's look at same period last year. So I'm jumping back to, jumping back to January 2nd. That happens to be the same value. So let me go to another month here. And let's look at month to date. So if we look at the current amounts, you can see that here I have 113, 235, 214, et cetera, for each of those individual dates. If I wanted to see the month to date total, so let's go down to January 11th, you can see that 1294 is the month to date total. So, you know, that's kind of tricky, and it gives us a lot of flexibility. It gives the user the ability to essentially say, this is the perspective that I want to see. I want to choose a different kind of time series measure, but I just want to see it in one place. How do we do that? Well, we do that through what's called a disconnected slicer and a dynamic measure. So let's talk about the disconnected slicer first. You can see that this slicer is based on a table called selected measure period. If we go back into the model, you'll see that selected measure period is just a table floating out in space. It's not related to anything. I actually created that table just by entering values. Okay, so there's my selected measure period. I'll zoom in on this. But I created this table simply by using the enter data feature. And then I just simply type those values into that table. It doesn't matter where that comes from. If you want to put that into a SQL table or an Excel spreadsheet or a SharePoint list, you know, it really doesn't matter where the data comes from. So we've just had this table floating out in space now that just has this list of values in that period column. Then we go create individual measures for each of these time series measures that I want to see, for current, for fiscal month to date, for prior year, etc. So you'll see that, let's see, are those, that's online. So you can see, here's my online sales quantity. This will be super simple. It's just the sum of my sales quantity, very simple measure. Let's go down and look at the date. Now I'm making a point to actually, oh, that's my fiscal month to date. I had to work a little harder to make fiscal month to date. Let's just go look at the month to date. Yeah, the month to date, I'm just using the total MTD. So simple time series measures, they're built-in DAX functions that you can use to do things like month to date, prior year, same period last year, etc. If I want to do a fiscal period, then I have to work a little harder. So there's an example of the fiscal period where I actually have to go apply an explicit filter and say, all right, if I want to get the year to date, then what that really means is I want the fiscal year in my my order date to be the same as the the relative fiscal year, and it needs to be the order date for my online sales fact table needs to be less than or equal to whatever date that I've selected. So the details of those DAX measures are not so important. What's important right now is that they exist. Then we create a dynamic measure, which I've called online sales quantity selected period. And this is what this measure does. So I'm going to create a slicer on my page based on that period column in that disconnected table. The selected value function in DAX will return a value when only one value has been selected in a filter or a slicer or appears in a group table. The switch function is essentially a bunch of nested if statements. So the switch function is essentially saying, all right, what is that value? If the selected period value is the word current, then I'm going to swap out this measure right here. If it is MTD, then I'm going to use that measure. If it's YTD, then I'm just playing this little shell game with my measures. Okay, so you've already seen how that can work in a slicer just by selecting a value. However, if I choose two of them, then it doesn't work because the selected value function is only going to return a value when a single value is in scope. So how can we contend with that? Well, what I've done, and I'm just going to delete that matrix and bring this one back. So in addition to being able to just see that dynamic value in a matrix visual, I can create a column group. So I'm going to take that same period column out of my disconnected table, my selected measure table, and I'm going to drag and drop that into the columns field well, which then is going to create a column for every value in that table. Now, if I don't have anything selected in my slicer, then you'll see everything. If I hold down Control and select a few of these, then you're going to see the items that I have selected. All right, let me pause there, take a quick drink of tea, and I'll ask if there are any questions. And I'm not seeing the chat window, and I think it's because PowerPoint has taken over my screen. So let me remedy that real quick.
Yeah. Anybody has any questions, you can just put it in the group chat window or.
So I have a question for you, Suresh. Since the weather is nice, somebody on my block has a leaf blower and the window is open. Do you hear that background noise that I'm yelling over?
I do not actually.
Okay, well, I think noise canceling is working in Zoom, but I'm going to naturally yell over the top of that background noise. So just that's why I'm yelling. All right. Well, let me know if there are questions. For some reason, I can't see the chat here in Zoom. It's because PowerPoint did something funky on this screen that I haven't selected.
So Ted was asking, if you have time, I would like to see how you handle MTD compared to MTD last year.
Okay. Actually, it wouldn't be that hard to do. Let's do this. Let me circle back if we have time, since I don't have. Oh, what the heck? Let's do it. It's gonna throw me a challenge. I'm up to it. Okay, so MTD was pretty easy to do because there's a function for that, total MTD. So there's probably a couple different ways that we could handle this. I'm thinking that I'm just going to take a fairly brute force method, which would be similar to the way I handled the fiscal month to date. So let's go create a measure. I'll start with my fiscal month to date, since the pattern is going to be very similar.
So Ted has more. With a custom fiscal calendar year, since few to no businesses use a calendar in general.
Yep. Say, I didn't get the very last part.
No, he's saying, with a custom fiscal calendar is what he was looking for.
Okay. Yes, I will show you the custom fiscal calendar that I have in this model.
Sounds good.
All right. So we're going to do MTD last year. Here, let's call it prior year MTD. And we'll zoom in. So the pattern that I'll use here, so we just took our modeling presentation and we've turned it into a intermediate DAX presentation now. So I have the online sales quantity, which is really just the sum of sales quantity, but I'm going to say I want my, I want to filter my order date table, which in turn filters my fact table. But by filtering the date table, I'm going to get that filtering in the fact table. So I'm going to do my filtering against the order date table. So the pattern here is calculate as the outer function, which essentially says, I'm going to establish my own filter context for this calculation. So pay attention to whatever I tell you to filter on. And then I'm going to use a filter function, which returns a table of filtered values, starting with a table reference. Now, here in my matrix, you can see that I have on rows my years, my months, and my dates. And so for a given date, this expression is going to be processed. And so because this is a date value, I'm going to say, I want to filter the order date table where the order date month that needs to be a month number, and I don't know if that's what it is. Let's use month name. We can do that. That'll work. It would be a better practice to have a month number, but we can do that since we want it to be within the same month. And as I'm working through this, I'm thinking that I probably want to do this in logical order, just so it makes a little more sense. But what we're really saying is that relative to a particular date, so let's say on January 6th and our data starts in 2007, so let's pretend like that says 2008. On January 6th of 2008, I want to go back a year relative to January 6th of 2008. I want to find the same day, so that would be January 6th of 2008, and then I want to get everything in that month that is less than or equal to that selected date, where the month is the same, but the year is one less. So let's try to work that logic now. So let me finish my month here. Copied that to the clipboard, but it didn't paste. Apparently I didn't. I'll just do it this way. All right, we go back and say, I want the year number to be one less. All right. So the year is one less than my current year, where my month is the same, and I need my day number. How am I going to do this? I really need a day number of the month, and I don't think that that exists.
Hey, Paul, that's okay. I was mostly curious if you added it again. I've solved it, I've battled it, I've done it a few different ways. I was mostly curious.
Yeah.
And
But you gave me a challenge here, Ted, and I'm not.
do it over a beverage of choice at some point.
So I believe that this is the answer. So if we
It's interesting because it's very different than how I've done it. And then I also had to go handle the weirdness of I'm often using 13 period accounting and then doing month. It's really challenging when you roll your own on a fiscal when you're in period 1. You have to do logic to go look at period 13.
well, and the thing with a custom calendar with custom periods is that it's all just math. You're just comparing numbers.
Exactly.
Yeah, and anyway, I'm going to back up and show you that. All right, but drum roll, please. Let's go ahead and add this. So we're quantity month to date. Where did it go? Sales quantity. Online sales. Prior, oh, that's because I didn't put quantity in here. All right, prior year month to date. Now we're gonna get that repeated over and over again, but that should still work. Let me just choose one column. And I told you that 2007 was the beginning of the year, so that won't be relevant, but it should be for my next year. And it is. And we also know from looking at this earlier that my quantity on January 2nd of 2007 was in fact 113. So we know that that's right. And we have evidence that the month to date is working because we see it accumulating. So there you go. Thank you for the challenge.
All right. Does that answer your question, Ted?
Yeah, that's excellent. That's excellent. And the irony is I just spent tons of time ditching all of the prior year comparisons because for all my retail customers, that's now a moot point. And I had to write everything to be prior week or prior months comparison because nothing compares to prior year for my restaurant company customers.
Okay.
All right.
So there was the question about creating a custom calendar. So let me give you instructions to create a custom calendar. Open your browser and go to Google. I honestly I searched for this and I found a good friend of the community had actually posted this quite a while ago, and that was Matt Allington, who is it Excel expert? Excel, I forget what his domain is, but he was with Power Pivot Pro at the time. Matt has written several excellent books like this one. But Matt had posted this on the Power Pivot Pro blog, I don't know, 5 years ago. He created a 4-4 calendar, and it's a lot of math and it's a lot of comparisons. And so I can't take credit for this. I have created similar calendars, and I can tell you that it's very much kind of a brute force kind of thing. But if you look at the M, you can you can essentially see what he's doing. The first thing that he's done in this query is he's adding an ID. He's just creating a sequential number that can be used to order all of the dates. And then he goes through and he does some math where he figures out where the fiscal years should be. And so he's dividing that ID by 364 to get his fiscal years. And then he's dividing that into periods and into weeks. And so, like I said, it really just boils down to doing the math and then rounding numbers up and down. So if we look at the steps here, you can see that we just start with a regular old date calendar. And here he adds his index. That was the step that I was showing you earlier. Here he's creating a fiscal year ID, which is that ID divided by 364. I think he then rounds that and truncates it. I'm not going to take you through all these steps because, you know, ask any accountant to create a financial calendar for you, and they're going to recommend a different method. It could be 445, it could be, you know, 454. It could be 13 period with a, you know, with a remainder adjustment period. There are a lot of different approaches, but generally speaking, the purpose of a financial calendar is to make sure that every single period falls within the year and doesn't bleed over into the next annual reporting period. And then, like I said, there's always a remainder, some kind of adjustment there. But that was the basis of my financial calculation right here. I'm sorry, my fiscal year to date calculation right here, where essentially I'm saying if I want the fiscal year to date, then all I really need is to know what my fiscal year is in the calendar and what date I'm on. And then I just do comparisons to say, just give me everything from the beginning of this fiscal year up to the selected year. All right. So the next topic that I want to explore, going back to our modeling discussion, is how to work without relationships. So we talked about disconnected tables, and you saw how this disconnected table could drive a slicer, and then I could use the switch function to essentially kind of play this shell game with measures that I've created based on what I've selected. That is the foundation of a design pattern that will take you far with creative reporting in Power BI. This is a topic that I'm just going to mention. I do have another model where I've built a composite model, but we have the ability and have had the ability for, I think, going on about 2 years now, to create a model where tables can either be imported, which means that a query runs, that data gets sucked in and stored inside the in-memory model, and then we run DAX calculations against it. It's very, very fast. That's kind of the natural mode of Power BI. And then other tables can be direct query. And a direct query table is not imported. We don't run a query ahead of time that then takes a copy of the data and holds it into memory. That table represents a query that gets re-executed and then passed back to the data source every time a user interacts with the report. Now, there are pros and cons here. Generally speaking, direct query is slow and limiting. However, if you have data that changes very rapidly and it's important to see those changes, direct query might be a good choice in that very special use case. Or if you have very, very large tables, and we're talking billions, trillions of rows, then direct query might be a better option than, you know, building, you know, tens of gigabytes, hundreds of gigabyte PBIX files. So this is essentially what a composite or a hybrid model is the ability to combine tables in different modes. We're not going to get into that in this demonstration. If you have specific questions, I'm happy to answer them. But we're going to get into some deeper modeling exercises now. So I'm going to step out of PowerPoint and we're going to take a look at, this is a question that came up. I remember the first time that this question was asked in a Power BI scenario. It was actually at the Orange County SQL Saturday. I'm thinking it was about 4 years ago. Ted had invited me to do a pre-conference session. And we were just doing kind of basic Power BI model design. And somebody who worked in the insurance business came up and said, I have a scenario that I haven't quite figured out how to build my calculations around, but we deal with insurance claims. And it's important for us to know what claims have been open and have not yet been closed as of a certain date. So how do I figure out if an insurance claim has been opened and is not yet closed? And how many of those claims do I have on a certain date? And I want to be able to trend that. And I had to think about it real hard and came up with a solution. I think this has become a fairly common design pattern since then. But we're going to combine the concept of a disconnected table, like we did before, with a dynamic measure that does some fancy filtering. So I'm going to show you the solution first, if I can find it. There we go, orders pending delivery. So since we're dealing with sales orders, you know, think about Amazon. My daughter works for Amazon, and the volume of open orders is a huge metric for Amazon. You know, I get an impulse to order something, and I pull out my phone and I order it, and that order is placed, and now it's in the system, which means that, you know, it's got to be pulled, it's got to be shipped, it's got to be boxed, and you know, all that costs money. And a company like Amazon is constantly racing against the clock to get that delivered, so they can say, took us 2 days to deliver that. Woo. So here I have a similar situation where I'm saying, in a certain date range, so right now from July 24th of 2009 through October 7th, just 2 dates that I've arbitrarily selected, I have 987 online orders pending delivery. The order has been placed, the order is in the system, but the customer has not yet received the order. And that's essentially what the insurance guy was looking for. So how do we do that? Well, we with a disconnected table to begin with. So on the x-axis of this column chart, I'm using a table that's not related to anything in my model called select effective date. I just went back to Power Query and I went and referenced my base date table one more time, and that resulted in my select effective date. I only have one column because I'm only going to select a date. I've decided that for my purposes, it's not important to deal with years, quarters, months, weeks, etc. So I only have a date in there. So if I were to plop that date onto my report canvas, you can see that I'm just going to get a list of dates. If I select one of those dates, nothing is going to happen because it's not related to anything. Actually, I guess it interacts with this visual because I've used the same thing, but nothing else in my report would be affected. All right. So now I need to create a measure that compares the order date and the delivery date to my selected date to decide if I'm between order date and delivery date. So that measure I've called online orders pending delivery. And that's what that looks like. So I'm using a variable here, And a variable is just a convenient way in DAX. It was a really horrible arrow. A variable is just a very convenient way in DAX to process an expression and get that value and freeze it. Just hold on to it. Then I can check that box and say, all right, I've dealt with that business logic. I went and got the selected effective date. All right, I'm holding that in this variable. Now I'm going to do a calculation very similar to the one that I did earlier by using filter with all. I'm essentially saying, for the purpose of this calculation, just counting the rows in the online sale, number of orders, for our purposes within the scope of this calculation, I just want to open up any filtering on the online sales table. And then I want to explicitly filter it and say, I'm interested in online sales where the order date is less than or equal to the selected effective date, and the delivery date in online sales is greater than the selected effective date. Okay, and that's it. It just works. Okay, any questions about that? So, who needs relationships anyway? I jumped over this slide a little bit. I'm not going to go full screen with it. But sometimes relationships can get in the way. That just sounds like a life lesson right there. But, you know, when we're modeling our data, we can run into anomalies sometimes where the inferred relationships between tables just don't work. And here's an example. So,
Paul, one quick question.
Yes.
Scott was asking, what will that work if delivery date is null?
That's a good question, and it would not. And so I would need to enhance that and say, or delivery date is blank.
Okay.
Glad you're paying attention. I do have a more enhanced version of that model where I did that exactly, and it's probably because somebody either asked the question or I tried it. It just didn't get in this model. So good question. All right. So we have two fact tables in this model. I've got online sales and I have store sales. Now it's probably no, sorry to make everybody dizzy there with moving things around. Probably no surprise that store sales have a store dimension, and online sales can also be related to a store, but not necessarily. Now, an online sale is not necessarily related to, oh, let me see, hold on, let me get my scenario right here. An online sale is related to a customer, and a customer has a geography. Okay, a store sale is related to a customer, and a customer has a geography. Therefore, if I want to see either store sales or online sales by geography, that is entirely possible because geography is related to customer. Okay, but a store can have a geography as well. So the big question now is, when a customer buys something online, do I care where the customer is located, or do I care where the store is located? And that's a business question that we need to answer. But because that relationship exists between store sales and online sales and store, because the relationship exists to customer and then customer is related to geography, if I try to relate geography to store, that relationship will not work. Now, I had just dragged and dropped the geography key from one table to the other, and you can see that that resulted in this dashed line. Since I'm zoomed in, I'll come down here. And you can see that the make this relationship active checkbox is not checked. Now, if I try to check that, I'm going to get this ambiguous relationship error message. And it says you can't do that because you already have a path between
look.
these tables.
I'm at my treatment.
So that's just not going to work. Now, there are a couple of DAX functions that will actually work with inactive relationships, but they're only there for semantics. And for our purposes, we're going to say that that relationship really serves no purpose. Somebody needs to mute their microphone.
Yeah, if you're, can you mute your microphone? I'm just trying to see. There you go. Thank you.
Okay, I'm going to zoom out here. So that we're on our way to deleting that relationship because it really doesn't serve a purpose when it's not active. So my question now is, can I get the store geography for either of my facts? Because I don't have a relationship that supports that. So let's jump over here and talk about how that can work. Sales. I got to remember where I use this. It wasn't there. Sorry, I've got a map on one of the pages and I've forgotten where it was. Okay, there we go. So how do we get the store sales quantity when I want to know the geography of the store rather than the customer? And this is how it's done. So the treat as function in DAX essentially lets me manufacture a relationship programmatically. So what we're saying here is that I don't need to have a relationship between the store table and the geography table in order to calculate the quantity for a selected geography. Okay, if I go click on a country, I should be able to get the quantity based on the geography of the store. And I do that using this treat as function. What treat as does is it essentially says, go get whatever geography, excuse me, the dogs are barking. Go get whatever geography records are in the current filter context. So if I've chosen a country or if I've chosen a location, then I'm going to get a table full of those keys. The values function turns that into a table that I can then pass into treat as. Take that collection of keys and treat that as if it were the store geography key. Okay. In other words, take that and make it that, and that is the same functional behavior as a relationship. And it just works, which means that if I go and select a geography, let me go back my map here. Yeah, let's just choose North America. Then we're waiting for that those numbers to update. And then you'll see this get recalculated. Okay, treat as is just one of the most magical DAX functions that there is. And I use it pretty heavily. All right, so with that, I just want to show you an example of where I have gone crazy with the treat as function. So here's an example of a report where I obviously have a number of visuals that will cross-highlight and cross-filter each other. You can see that everything is recalculating. If I choose July, then that's going to recalculate these numbers. If I choose the cameras and camcorders category that's going to cross filter everything. And yeah, that's what Power BI does. It just cross filters because of all my relationships, right? Not in this case, because with that exception, which I could actually delete, there are no relationships in this data model. And the way that I did that was by simply using treat as against a few different tables. This supports the modern belief that relationships are unnecessary. All right, so learn treat as. It will just change your world. You'll be able to do some really magical things with it.
Paul, can I ask a question?
Absolutely.
Have you done any performance comparisons using treat as versus a relationship on a larger model where it might have an impact?
Yeah, actually, this came up recently, and the answer was a bit inconclusive. I think we can make a good argument that relationships serve a purpose, and in a well-designed model, it's probably going to perform better if the relationships simply support your dimensional, requirements, if those relationships exist. However, in the testing that we did where we essentially had to use treat as, it performed extremely well. So it was for a consulting client. This was probably 2 months ago. We opened up DAX Studio and we went and captured queries using relationships and then compared those with treat as calculations. And we looked at the time spent in the formula engine versus the storage engine, and all of that stuff you're supposed to do to debug DAX queries. And it was a marginal difference, and I think the relationships won, but not by a huge margin.
Thank you.
You bet. Other questions? Because I'm actually nearing the last slide here, and we're right at the end of our demos.
Anybody has any other questions? You can post it on the group chat, or you can unmute yourself and ask.
Let me go ahead and just take us to the concluding slide. So what's interesting is that when Power BI was originally released, because Microsoft made a point to really target their competition and try to meet them feature by feature. The biggest competitor, of course, in the self-service BI space was Tableau. Close behind that was Click. Tableau in particular kind of made a big deal about it being unnecessary to do IT-centric modeling, and that their tool just kind of did black magic, and you didn't have to know how to build star schemas and that kind of thing. And Microsoft kind of preached that gospel a little bit, and then everybody created these really hideous data models. And I work with customers who will bring us a Power BI model that they've been evolving over 3 or 4 years. Somebody started and they, they may have started out of the business, and so they weren't really adhering to correct modeling practices, and then it grew and it grew and it grew. And the solution to a lot of those problems has been to go back to the drawing board and create a correct dimensional model. That has solved the problem in 95% of the cases before we go and do real fancy things with DAX. So this is an article that makes that point. I believe that this was Marco Russo, who, on SQL BI, talks about the importance of star schemas, and the product team has really kind of supported that now and saying, you really ought to go through the same dimensional modeling exercise that we've been going through for years. We just didn't want business users to be scared of using Power BI, so we try not to make it complicated for them. good articles here on many-to-many relationships and model optimization and then direct query. And then I have a number of posts on my blog where I talk about modeling exercises. And I'm happy to answer questions through my blog and the other contact methods that I've shared with you as well. Do we have other questions?
Any other questions regarding modeling, or anybody heard about XMLA? Do you have any questions about XMLA?
Well, let me ask this question. I don't have visibility to how many people we have in the meeting right now. How many people do we have attending right now? I just see the top of the list.
We have about 23.
Okay, so of the body of 43, I'm going to ask everybody to chat. Who of you are either now or will soon be using Power BI Premium as opposed to Power BI Pro or just desktop? How many are using Premium? I can get back to where I can see what's going on in Zoom.
Yeah, I have one more apart from me.
So shall I spend a few minutes just talking about the XMLA endpoint and what it is?
Yeah, I think it's going to help a lot.
Okay, so this will be a teaser. So about a year and let's see, it was March of last year. So about a year and 3 months ago, Microsoft released the read-only XMLA endpoint in Power BI Premium. Now, you know, if you're newer to Power BI, you may not know that Premium is a subscription model for Power BI that essentially allows, well, there's two things. It gives you dedicated capacity, which means you buy a certain amount of capacity and you're guaranteed to have that capacity so that you don't compete for resources with other Microsoft customers who are using the Power BI service. And it allows an unlimited number of people within your organization to access Power BI reports. So you could, you know, you build data sets and reports and dashboards, and you put them in a workspace, and you package them in what's called an app, and then that app becomes the mechanism that your users use to interact with your report visuals. And for the low price of $5,000 a month, you can get started using Premium, unless you know are not for profit or education and get discounts otherwise. So that's a pretty steep entry point for a lot of folks, but that is really going to be the preferred way that Power BI will be used in organizations. And I think in the near future, we will see more affordable entry points for the Premium feature set. You know, I can't guarantee anything, but this particular feature is a Premium only feature. Premium is not only about getting the same stuff at a different price. It's about a whole boatload of features and capabilities that are Premium only. So let's talk about what the XMLA endpoint is real quickly. I'm going to let this slide build, even though I've already shown it to you. So some TLAs, 3-letter acronyms. What's XML? Way back when, this is how everything was defined. You know, it was all the rage in the late 90s and the early 2000s. You know, Word documents, Excel workbooks, internally, all that stuff is described using XML. JSON essentially has replaced XML in the modern world, but Microsoft and several other vendors established a data definition language for analysis services that was based on XML, so they called it XMLA or XML for analysis. It's now JSON based, which is a much better markup language. It's lighter, it's more robust. Analysis services objects such as tables, connections, measures, relationships are all defined in a programmatic object model called the tabular object model, which we call TOM for short. The scripting language that you use to define those objects is called the tabular model scripting language, or TMSL. All right. TMSL is a JSON-based scripting structure that is a subset of the XMLA standard, even though it's not XML based anymore. They still call it XMLA. So that's why it's XMLA. I promised to make this short, so let me back up. So for enterprise scale models, we have been recommending two different platforms. We've been recommending Azure Analysis Services as the modeling platform within Azure. That's a pay-as-you-go service. Customers who I'm supporting are paying anywhere from $1,000 a month to $3,000 a month for Azure Analysis Services. Power BI Premium is a little more expensive than that. It has more features. Power BI Premium is really kind of becoming the replacement for Azure Analysis Services. And the XMLA endpoint enables that to happen. It essentially provides connectivity for any tool. Anything that knows how to talk to analysis services will now know how to talk to a data set in Power BI. And you can get started if you want to play with this without going out and spending $5 grand. You can go to your Azure portal and you can set up an embedded capacity. And that's exactly that. You go out to Azure and you type embedded, and this will show up, and you create a capacity. It needs to be set to the A4 level, and you can turn that on and turn it off. And while it's on, it's going to cost you about $8.50 an hour to have that turned on. But you can light that up as a capacity, a dedicated capacity within your Power BI tenant. And then that gives you access to the XMLA endpoint. By default, the XMLA endpoint is read-only, which means you can read from it. You could use it to query against, but you can't change objects. But if you flip it over to read-write, which is in preview, then you're able to interact with the server. So what this allows me to do, and I'm going to demonstrate this using a customer's project because I didn't turn on my, my capacity. I'm just going to show you the environment where we can do this. So I'm going to go to Power BI. This is for a school district in Georgia. Within this workspace, I'm going to go to Settings. You can see that this is a premium workspace because of the little diamond right there, and you can see that I have premium turned on. And with that XMLA endpoint turned on, I get this workspace connection. And I can copy that to my clipboard. You can see that the name of the workspace is there at the end. So this is a web service endpoint. It's just a method that I can connect to the analysis services instance that lives behind the Power BI service. So I'm opening SQL Server Management Studio, and I'm going to use SSMS to connect to a Power BI data set now through the XMLA endpoint. And we're going to sit here and watch the splash screen. Just while we're waiting for this to open, essentially the idea is that there's a lot of capability that we've had in analysis services for a very long time. This is, analysis services has been around for 23 years now. That we don't have exposed through Power BI, simply because Power BI was designed first to be for self-service and secondly for IT enterprise-based solutions. So I'm going to connect to analysis services. Let me zoom in here. And so again, I'm using a client's environment. So there I've pasted that endpoint. And then I'm putting my credentials there. I'm going to connect. I'll go ahead and zoom back out. And this is where the magic happens as soon as we get a connection. Okay, zooming in again. So you can see that my endpoint shows up as if it were an Azure Analysis Services instance. And I'm going to open up databases, and you're going to see that all of the data sets that have been deployed to this workspace will show up as Analysis Services databases. And I can see that there are connections, tables, roles. I can go down to tables. And let's say that I want to create a partition. That's not something I can do in Power BI, aside from using the incremental refresh feature, which is very automated and somewhat restrictive. But if I wanted to, let's say, let's do my, well, we'll just do, what has a date in it, current grades maybe. So I could go here and I could see the partitions that are behind that table. Zoom out, and I can script that partition here. And if I wanted to go build additional partitions, I could leverage this script, change the partition name, change my filtering criteria, and away I go. And so this gives me a tremendous amount of flexibility. What you're seeing here is an M-based query. And so I would have to add a filtering step, and I'd probably use a date range to say this partition is for records in 2018, and then another partition is for 2019, and another partition for 2020. So that is the gist of the XMLA endpoint, and just a peek into what it can be used for. Going forward, we can use the XMLA endpoint to have one Power BI data set read data from another Power BI data set, because it's just an analysis services connection. So we can kind of create our own hybrid models that way. We'll be able to do automated builds and deployments. We can use Visual Studio, SQL Server data tools to manage a data set, which gives us version source code control and version management and application lifecycle capabilities. Again, things we haven't had in Power BI in the past. So why don't we cap that off there, see if there are any questions on that topic.
Any questions, anybody? This is pretty interesting, Paul, and it's one of the features that's upcoming, right? So I'm curious to play around with it in Power BI Premium.
Yeah, and this is for the enterprise. This is if you're getting started with Power BI and you're a self-service business user, you're not going to have to learn this. It's not going to be super important to you. But
Right.
for those of us who do larger scale enterprise BI solutions, this is pretty big news.
Yep. Yep.
So with that, I'll go ahead and wrap up and turn the time back over to you, Suresh.
Sounds good. Thank you. Thank you very much, Paul. Really appreciate it. I learned a lot from this session. Anybody has